Okay, welcome back for the very last domain, Domain 8, Software Development Security. Here we explore how security is woven into the very fabric of building and maintaining software. Think of it as learning to lock every door and window while you're still designing the house. From writing clean, safe code to evaluating third-party tools, this domain teaches you to build security into innovation, not bolt it on later. Let's get started. So imagine you're building a family photo sharing application. Before you touch a keyboard, you decide how pictures are protected. In design, you restrict access only to family members. And when coding, you add encryption. Testing becomes your practice breach. You try and break your own system before anyone else can. Security isn't a stage. It's a thread running through the whole software development lifecycle. That same principle applies in every enterprise software project. Your GitHub repo is your digital workshop. You wouldn't let anyone push untested code straight to production. So you enable branch protection, require peer reviews, and let automated scanners hunt vulnerabilities. You even reduce your own admin rights because mistakes happen fastest at full privilege. Securing the pipeline is securing the process of creation itself. You just don't hope your app is secure. You measure it. By reviewing logs and alerts, you discover trends. Are my login attempts increasing? Maybe a library used has a new CVE. Risk analysis tells you whether to patch or replace it. Assessing effectiveness means moving from guessing to evidence. Security maturity is measurable, and those metrics guide smarter fixes. Buying software doesn't buy safety. When you subscribe to that cloud invoicing service, you evaluate it. You check if data is encrypted, review update cadence, and disable unused public APIs. Enterprises perform similar vendor risk reviews and demand SOC 2 reports or pen test results. Integration without verification is how supply chain breaches begin. Good code defends itself. When you restrict uploads to image files, you're practicing input validation. Encoding user comments blocks cross-site scripting. Ownership checks enforce least privilege. And pruning libraries keeps dependencies clean. Secure coding is about humility, expecting errors, anticipating abuse, and designing resilience. That mindset turns developers into guardians of trust. So far, you've built a fortress with thoughtful design and clean code. But even the strongest castle needs inspection. Let's transition from building securely to proving it's secure through metrics, review, and continuous learning. Time to test your CISSP mindset. But before we jump into the quiz, here are a few things to keep in mind. CISSP questions aren't designed to test how many facts you can memorize. They test how you think. You'll often see multiple answers that look correct from a technical point of view, but your goal is to choose the best next step or the option that reflects sound, risk-based judgment. Always approach each question from a risk advisor and managerial perspective. Ask yourself, which choice best supports business objectives while minimizing risk? That's the mindset the exam is built around, and it's what separates someone who knows cybersecurity from someone who can lead it. Let's get started. Question 1. During software development lifecycle planning, the business team demands rapid release cycles with minimal testing. As a security lead, what's your best course of action? A. Integrate automated security testing into CI/CD pipeline. B. Refuse release until full testing completes. C. Delay release until manual review by InfoSec. D. Accept risk and document the exception. The correct answer is A. Integrate automated security testing into the CI/CD pipeline. Embedding automated security tests supports both speed and assurance. The CISSP CISSP way of aligning business goals with risk management. Question 2. A developer bypasses peer review to push emergency code that fixes a bug but introduces a vulnerability. What's your priority action? A. File a post-deployment incident report only. B. Run a vulnerability scan later. C. Discipline the developer. D. Roll back the change and follow change control process. The correct answer is D. Roll back the change and follow change control process. Restoring integrity of the process takes priority over punishment. Roll back, document, and re-implement through proper channels. Question 3. Security metrics show low patch compliance in development VMs. What's the most strategic management step? A. Audit each VM manually. B. Ignore. Dev environments aren't production. C. Rebuild all systems from backup. D. Enforce automated patch baselines and measure improvement. The correct answer is D. Enforce automated patch baselines and measure improvement. CISSPs choose scalable, measurable solutions, not manual inspection or neglect. Question 4. Your company purchases an analytics software as a service that stores customer PII abroad. What's the first action before integration? A. Sign a data processing agreement. B. Enable multi-factor authentication for vendor portal. C. Request pen test results. D. Encrypt local backups. The correct answer is A. Sign a data processing agreement. Legal and contractual safeguards establish accountability before technical integration. This is foundational risk governance. Question 5. Developers insist on downloading open source libraries freely. What should you implement to reduce risk without stifling productivity? A. Perform manual review for every commit. B. Ban all open source usage. C. Create an approved repository and scanning policy. D. Allow unrestricted usage but log activity. The correct answer is C. Create an approved repository and scanning policy. This is the managerial sweet spot. Question 6. Which approach best demonstrates secure by design? A. Perform quarterly audits. B. Add encryption after testing. C. Embed threat modeling in early design. D. Train developers after release. The correct answer is C. Embed threat modeling in early design. Threat modeling before code exists weaves security into architecture. Prevention, not correction. Question 7. A new developer disables static analysis tools to speed builds. What should security management do? A. Permit the change due to time pressure. B. Ignore since code passed review. C. Re-enable tools and escalate noncompliance. D. Add manual testing later. The correct answer is C. Re-enable tools and escalate noncompliance. Management enforces baseline controls to preserve assurance and audit traceability. Exceptions require formal approval, not convenience. Question 8. Penetration testers find that input validation is inconsistent across modules. What's the long-term fix? A. Patch only vulnerable modules. B. Run weekly scans. C. Create a shared secure coding library. D. Train users not to submit bad data. The correct answer is C. Create a shared secure coding library. This standardizes defense and reduces future technical challenges. Question 9. Which metric best demonstrates effectiveness of software security controls? A. Lines of code produced. B. Frequency of commits. C. Reduction in high severity vulnerabilities after each sprint. D. Number of bugs closed. The correct answer is C. Reduction in high severity vulnerabilities after each sprint. CISSPs value risk reduction metrics, less impact and exposure, not activity volume. Question 10. After years of updates, your legacy application can't support modern encryption. What's the most appropriate CISSP aligned action? A. Rewrite immediately, regardless of cost. B. Remove the encryption module entirely. C. Ignore until breach occurs. D. Apply compensating network layer encryption while planning replacement. The correct answer is D. Apply compensating network layer encryption while planning replacement. Apply compensating controls to maintain protection while planning long-term remediation. This balances risk, cost, and continuity. Now let's briefly discuss how each of these questions reflect real CISSP thinking. Each one is designed to test judgment and layered reasoning, not just memorization. Now, will most of the questions in the exam be this simplistic? No, but the concepts still apply. The exam often focuses on identifying the best next step or the underlying principle being applied. That's one of CISSP's favorite tricks. And here's the challenge. Many answers will sound technically correct, but only one truly aligns with primary intent, the most appropriate action from a managerial, risk-based perspective. That's what separates a good technician from a true CISSP. Okay, and that's a wrap for Domain 8, Software Development Security. Congratulations, you've completed all 8 domains and you are ready to take your exam. I wish you the very best of luck, and please come back and let me know how you did. See you next time.